Hello everyone, in this video I'm gonna talk about indexed access types, or in other words, lookup types. This video is based on my article about indexed access types. Let's start. I will open VS Code. We have a simple interface that describes the user in some application. Here we can query the types of the user interface's properties like ID, name, and address. We can even query the types of the nested properties like the street and the city. I will explain how to do it. Let's say I need to create a function for updating the user address. First, I need to get the ID of the user. Instead of using a number to describe the ID, I will query the actual type of the ID, like this user square brackets, then the property name, ID. So the ID parameters type will refer to the type of the user interface's ID property, which is a number at the moment. Now let's take the user's new address as the second parameter and query the type of the address property of the user interface. The type of the new address property now is the user's address object. So these types are called indexed access types or lookup types. To access a nested property, for example, street or city, we can do the following. For example, let's access the type of the city. So I say user, square brackets address, and then square brackets again, and city. So the city type is a string here. Also, we can get the types of multiple properties at once. For example, we can get the type of ID and name properties as a union, like this. Let's call it ID or name and say user. And then we provide a union of ID and name. And as a result, we get a union of the types of these properties. String for the name and number for the ID. Looking at this function, you might say, hey, why didn't you create separate types for ID and for the new address parameters? I can create the type for the ID property separately, like this. And the type for the address. I will move the type from here. Okay, and for the ID, let's use user ID. Oh, it should be interface. I wanted to create an interface. Now I can use these new types to describe the parameters of this function like this. User ID and new address is user address. So splitting a large type into separate types is fine as well, especially if the smaller types are going to be reused. But there are cases where we need to reuse a part of a type in a few places and it doesn't make much sense to move that part into a separate type. Also, the lookup type is useful when we need to reuse a part of some type that we cannot touch, like for example a type from a third-party library. Let me show you an example. I will create another file, call it third-party. Let's imagine that it's a third-party library. I will move the user type here. First, I will restore the user type to its initial shape. And move this type to the third-party package. From here, I will export it and import it to our index. Okay, so the user interface is the only type that is exported from our imaginary third-party package. So in order to get the type of the address, we have to use an indexed access type here. Otherwise, we would have to create this type ourselves. Also, to make this look nicer, we can create a type alias for our indexed access type. For example, we can create a type alias for the user ID and the user address. And use these types further in our application. Like this. Isn't it cool? I think it's cool. Now I would like to explain the keyof operator, because we can combine this operator with indexed access types in more advanced scenarios. So I will explain the keyof operator first. The keyof operator is used to query the names of the properties of a type, like here ID, name, and address, and represent them as a union. So let's go back to index. Let's get the property names of the user interface as a union. I'll call it user properties and say keyof user. The result of keyof user is a union of the property names of the user interface here, ID, address, and name. Also, I would like to mention that type keyof subtype is a subtype of string. Let me show an example. I'll create user property variable of type user properties. The user property variable should have one of the property names of the user interface. So let's pick ID, and I will create a string of type string is equal to user property. So I can assign user properties to a string, but I cannot assign any string to the user properties type. So if I say user property is equal to some string, I will get an error. Now let's see how we can use indexed access types, the keyof operator, and generics together in more advanced scenarios. We can use the indexed access type together with the keyof operator, for example, in order to describe a function that reads the value of a property from a given object. So I will remove this line so it doesn't bother us and create a function. Get property. This function should return the value of a property of a given object. So let's get the object first. It can be any object, so let's use a generic type parameter to describe it. T, so object is T, and we need a key. This is the name of the property that we would like to read. So we can say string, for example, like any property. Then let's return object key to read the property. But we can't do this. TypeScript produces an error. Let's have a look. Element implicitly has an any type because expression of type string can't be used to index type unknown. TypeScript doesn't know what kind of value to expect for the object parameter. So it says, hey, let's treat this parameter as unknown. So object is unknown for TypeScript. And then TypeScript looks here and says, hey, they are trying to access some property of something that is unknown. And the property name they provide can be any string. So TypeScript says, hey, I cannot let this happen. It's not possible. You cannot access any property of something that is unknown. So to make this example work, we should explain to TypeScript that the key parameter here is the name of a property that exists in this object, T. And this is the time to use the indexed access type together with the keyof operator. Before we continue, I would like to mention that I've got this example from the TypeScript handbook. So we need to get the type of the key as the second generic type parameter, because the name of the property is going to be dynamic and will depend on the object. So we can name our generic type parameter for the key k and say it extends key of t. Basically, we say that k should be a property name that exists in the type t. Let's use k to describe the key here. Okay, and now TypeScript knows that the key parameter is the name of a property that exists in the object t. Let's test this function. I will create some object, let's say user. The user has age, let's say 25. Now let's get the value of the name property from the user object using getProperty. First, let's pass the object user, and as a second parameter the property name. Let's get the name. And TypeScript here, if you check the name, the type of name, TypeScript inferred the type of the name property correctly. It's a string. Let's try to get the age. and age is a number. So TypeScript infers the return type of this function properly, so it's a useful function. Also, TypeScript will produce an error if you try to assign anything other than the name or age, which are the properties that exist in this object, user, to the key parameter. So for example, if I misspell a property name here, I'll say names, I will get an error from TypeScript here. So let's fix it. Okay. Now let's look at another more advanced use case. A similar pattern is used to describe document advent listener in the DOM library included with TypeScript. So let's see what it is. Document advent listener. The document's advent listener method allows us to register an event listener function for a particular event that occurs on the document. As the first parameter, we specify the event name, like for example click, and as the second parameter, we specify the event listener function. And this function takes a parameter, the event object, that describes the event. Okay, and the event object here for the click event is inferred to be mouse event. So TypeScript inferred the type of the event parameter in the callback here from the name of the event we provided as the first parameter. If you try to, for example, add an event listener to some keyboard event, like for example key press, TypeScript will infer the type of the event parameter here to be keyboard event. So for the click event, TypeScript inferred E to be mouse event, and for key press it inferred E to be keyboard event. This pattern looks useful, so I tried to create a simple example. I created two interfaces to describe two different event objects. So I created interface my mouse event that describes mouse events. A mouse event has the mouse location coordinates like X number and Y number. And another interface that I created is to describe a keyboard event. My keyboard event. The keyboard event should have the information about what key the user pressed. Let's call this key, okay, string. Then I created another interface, my event objects. We will use this interface to map event names to the corresponding event objects. For the click event, the event object is going to be my mouse event, and the corresponding event object for the key press event is my keyboard event. Now let's create a function that registers an event listener for some event. Let's call this function handle event. We should get two parameters, the event name and the callback. That is going to be executed when the event with this name occurs. Let's use a generic type parameter k to describe the event name. K extends keyof my event objects. So the event name k is one of the keys of the my event objects map. Here it's click or key press. Let's describe the event name parameter using k. And in the callback, okay, we get a function that doesn't return anything. And as the parameter of this callback, we're going to pass the event object related to this event name. So we can say E, and this object will be of type my event objects, this map, and we will index into the event name that the user provides. Okay, so I'll say K here. So when we call this function like this, handle event, we provide the name of the event, let's say click, and then we provide the event listener, and the event object here is going to be my mouse event. Okay, and for key press, it's going to be my keyboard event. So this type declaration works like the one in the add event listener. And actually this is how add event listener is described. If I open the type definitions of this function, here it has two overloads, but the overload I'm interested in is this one here. So the author describes the event name here using the k parameter here. And the k parameter is one of the keys of the document event map interface. Okay, so the document event map interface contains mappings of event names to their event objects. And then they use document event map together with k here to describe the event object we get in the listener function. So basically I have just simplified this declaration here. Then I tried to implement the handle event function. So I decided to be straightforward with it, and then I said, hey, if event name is equal to click, then I wanted to call the callback with the click event object. So I called callback and provided the event object for the mouse event object. Like I said, x is equal to 1 and y is equal to 1. So it's a mouse event object with x and y properties. Okay, and I got an error. And similar with the event name keypress. So else if event name is equal to keypress, then call the callback with the key property. Key, let's enter some key, like enter. Okay, so basically in here, I tried to narrow the parameter of the callback, this parameter, to a more specialized type. So for click, it should have been my mouse event, and for keypress, it should have been keyboard event, sorry. When I checked whether the event name is click, I expected TypeScript to infer the parameter of the callback to be my mouse event, because TypeScript infers the type of this parameter correctly when the handle event function is called here. So E is my mouse event. Basically, inside of the click if block, I told TypeScript that generic type parameter k, here, click, k, so the parameter k is equal to click here inside of this if block. And I expected TypeScript to substitute click for the parameter k here in the declaration of the callback. But this didn't happen because TypeScript didn't recognize the relationship between event name k here and the type of the parameter e, here my event object's k. Then I figured out that TypeScript infers the type of the callback's parameter e to be an intersection of my mouse event here and my keyboard event. Here, if I hover over this error, I can see that TypeScript says that I cannot assign this kind of object to the type my mouse event and intersection my keyboard event. And TypeScript cannot narrow this type down to a more specialized type inside of the function after the parameter k becomes known. So to fix these errors, we would have to use an assertion. So I have to say here as my event objects k, and this works. And same here. So this is how it works, at least at the moment. Then, because I figured out that TypeScript infers the e parameter here to be an intersection of the values of the my objects interface, so my mouse event and my keyboard event, I tried to evaluate the expression that looks similar to this outside of this generic function. So I created a type alias, my events, and said my event objects. And then I used keyof my event objects for the index. And I've got the following type. My events is a union of my mouse event and my keyboard event. So we have the OR operator here instead of AND. So it's not an intersection. While here, with this type, it's an intersection. So if you substitute for k, this keyof my event objects, we will get exactly the same expression as here. So if we use the keyof my event objects directly for k, we will get a union of my mouse event and my keyboard event. But if we use K instead of this, we will get an intersection, okay? So this was my observation of this pattern. Hope you found it useful. And finally, we've got to the end of the video. Here, I would like to mention that I created a quiz based on the information I talked about in this video. I think a quiz can help to better understand the new information. So I will add the link to the quiz in the description. If you liked the video, hit the like button and subscribe. Have a nice day and see you in the next video.